Welcome to The Explainer. Today, we're going to climb the ladder of language AI. We're going to figure out how machines went from seeing our words as just total gibberish to actually, finally, understanding you.
You know, it's something we just take for granted now, right? You ask your phone for the weather, you tell a chatbot what you need. But think about it. How does it actually get what you're saying? Bridging that gap between our language and a machine's logic, well, that was a monumental problem that took decades to crack. Because to a computer, our language, all of its richness and nuance, it just looks like this, an endless stream of zeros and ones. It has no idea what want or eat or chocolate even means. So the very first challenge was, how do we even start translating our words into something, anything, a computer can actually work with?
So the first real crack at this problem, way back in the early 2000s, was, kind of beautifully simple. Instead of trying to teach a machine meaning, which is super hard, researchers just decided, hey, let's just teach it how to count. And this first rung on the ladder is called the bag of words model. And the name is, well, it's pretty literal. You can actually picture it. You take all the words from a sentence, toss them into a bag, shake it all up, and completely forget what order they were in.
Okay, so here's the nuts and bolts of it. The model has this master list, a vocabulary of every single word it knows. So when it sees a sentence, it just goes through that list and counts. How many times did this word show up? How many times did that one? And what you end up with is a simple list of numbers. That's it, a vector. But, and this is a big but, here's the huge flaw. Just look at these two sentences. Dog is cute, and is dog cute? Now to us, one's a statement, one's a question. Totally different meanings. But to the bag of words model, they're exactly the same. The word count is identical, so the numbers it creates, they're identical too. So the machine had numbers, which, hey, it's a start, but it had zero grasp of what the words actually meant. It couldn't tell a question from an answer. That really crucial piece of the puzzle, the actual meaning, was completely missing. All right, so that brings us to the next big leap. This happened around 2013 with this really brilliant idea called word-to-vec. And this was the moment we finally moved beyond just counting words and started trying to understand what they actually represent. So the whole point of word-to-vec was to create these number representations. They call them embeddings. They captured a word's actual meaning. The core idea was super intuitive. Words that mean similar things should have similar numbers. And the researchers behind it asked this really powerful question that basically changed everything. They said, what if a word's list of numbers wasn't just a count? What if it was more like a coordinate, a location in some kind of meaning space that's defined by how it relates to everything else?
I love this because it gives you a great way to picture this. Just imagine every single word getting scored against hundreds of different concepts, like, is it an animal, or does it have a tail, or is it something you find in a house? And by doing this, you end up creating this unique semantic fingerprint for every word.
And because of these unique fingerprints, the machine could suddenly do something amazing. It could use simple math to see that, hey, the numbers for cat are way closer to the numbers for dog than they are to the numbers for house. This was a massive step forward in capturing that relationship between words. But as revolutionary as word-to-vec was, it had this one huge, lingering blind spot, a problem that it just couldn't solve on its own. And it's a problem that you and I deal with effortlessly every single day. I mean, just think about the word fan. A ceiling fan is obviously not the same thing as a sports fan, right? The only way you know the difference is because of the words around it. The meaning is all about context.
The problem was, word-to-vec's embeddings were static. That means the word fan had only one fingerprint, one set of numbers. So it was totally blind to context. To the model, a ceiling fan and a sports fan, they were exactly the same thing. And that's a huge problem.
So this leads us to the final and maybe the most important question. How could an AI possibly understand that the same word can mean different things? How could it create dynamic fingerprints that actually change depending on the sentence they're in?
And that brings us to the top of the ladder, the modern solution. Let's talk about how today's AI, like ChatGPT, finally cracked the context problem and kicked off the revolution we're all seeing today.
So let's jump to a landmark year, 2017. This is when a totally new kind of AI architecture was invented, and it changed, well, pretty much everything. It was called the transformer.
Okay, so the secret sauce inside the transformer,
is this incredibly powerful idea called the attention mechanism. And it's exactly what it sounds like. It's a way for the model, as it looks at one word, to pay attention to all the other words around it to figure out the right context.
And this is the brilliant solution. Attention lets the model create these contextual embeddings that change on the fly. So now, the number fingerprint for fan in ceiling fan is completely different from the one for fan in I am a fan. It gets it, and it uses this deep understanding of context to generate text, one word at a time, always building on the meaning it just figured out.
You know the title of that groundbreaking 2017 research paper that introduced all this? It really says it all. Attention is all you need. That one single mechanism was the key. It unlocked the final door to true language understanding.
And there you have it. That's how we climbed the ladder. We went from just counting words in a bag to mapping out their meanings, and finally to understanding them in context. It's that journey, that progression, that powers the amazing AI we all use every single day.
So what we've really seen is this incredible evolution, right? Each step building on the last, solving a deeper and more difficult problem. And all of this leaves us with a pretty fascinating thought for the future. Now that AI actually understands us, what conversations are we going to have next?